this video we're going to take a look at 2's complement. Now we've already looked at sign and magnitude, which is a method of representing negative numbers. The alternative method, and arguably the better method, is 2's complement. So similar to an analog counter, like you see on like cars and things like that, for the mileage, if you turn 000 back one, it will equal 999 at the top of the counter. So if it's the same thing in binary, taking away 1 from 000, it's going to give you 11111, which is -1 in binary. Okay, so to do this, what we do is we just flip all the digits. So if it's a 0, it's a 1, if it's a 1, it's a 0, and then add 1. So you see for -3, the value is 1111110 1. Okay, really simple. So flip all of the bits and add 1. Think about 0 there. 0 is just 0 because we'd flip it, which would give you 1111. We'd add 1, which would put it all back to zeros again. Okay, so if you think about, we've got 3 here. +3 is just 1 1 with loads of zeros. -3 is all ones. 0 1, just like that. So if we're going to do a question in this, you get told, right, you need to find -77 in denary. What we do is we find the positive value first, however you want to do that. Okay, so we've got 64 plus 8 plus 4 plus 1 gives us 77. We then flip them all, so the 1 becomes a 0, 0 becomes a 1, and so on, and add 1, which changes this very first 0 into a 1, which gives us -77. Now, one thing we have to think about is that the number of values that can be represented is reduced. Okay, so because we can't use the MSB, because that's telling us if it's 0 or 1, we can only have 127 numbers. Okay, so the biggest number you can get positive is 127, and the minimum is -128. Now, if you want to do any subtraction, what we have to do is just add the two values. So if I want to do 6,510, take away 4,310, all I would do is do 6,510 plus -4,310. So what we can do is just 2's complement that second number and add them up. So instead of doing all the carrying and borrowing like we did in the subtraction before, what we can do is we take 6,510 and add that to the 2's complement of 4,310, which will give us that final answer. Now you see we've ignored the carry bit there. That's because the number's still going to be positive. We just ignore overflows in this specification. We don't even have to worry about it. You won't even get asked about it. We just ignore the carry bit. So our answer is 0 0 0 1 0 1 1 0. Obviously, if we did keep that carry bit, it sort of ruins the whole process because we've then got this extra 1 at the start, which is going to make the number suddenly massive for no reason. As we said before, all we're going to do is ignore any carry bits. Any carry bits like that end up going overflow past the 8 bits or whatever they say. If they give you a 10-bit binary number and you go into 11 bits, then we need to ignore the 11th bit. It depends on the question, but it will mess with things. So it's really important that you ignore that. You can still do it as normal, but just scribble it out, put a line through it, something like that. So now we're going to take a look at how we do it in an exam format, looking at an exam question. This question actually comes from the previous question, talking about sign and magnitude. So we've already converted and found out what 119 is. So we know that it is 0 1 1 1 0 1 1 1. So that is our number. Now to convert to 2's complement, what we have to do are 2 ways. We can either flip all of them, add 1, pretty easy to do, or we can do a different way where you start from the first one and flip from there. So we'll go with the easier way because it's a straight swap. So all we do is if it's 1, you change to a 0. So we've got 0 0 0 1 0 0 0 1. Now all you do now is binary add 1 like that. So our final answer would be 1, then 0 0 1 0, 0, 0, 1. And that is our answer. And we know it's a negative number because we're starting with a 1. Okay? That is a 2's complement version of 119. The alternative way seems a little bit weird. So if we do it with the same number, so I'll just divide it up so we can tell. So if we've got 0, 1, 1, 1, 0, 1, 1, 1, all we do is we convert, but we start from the left, to the right, sorry, go into the first number on the left. So if we get a 1 here, so if there's loads of zeros, you ignore them. As soon as you get to a 1, you keep that 1, then you flip. So 0, 0, 1, 0, 0, 0, 1. The number's exactly the same. That's the other way. I learned using this method, but I think for easiness, flip the whole thing and add 1. This is actually the easier method.